In today's video, we analyze several videos that claim to achieve infinite energy with an inertia wheel or debunk it because they couldn't make it work. Stay until the end to understand why our system does work. In recent weeks, social media has been buzzing with videos showing machines supposedly capable of generating energy without fuel or external power. These devices claim to operate using energy stored in springs. Today, we'll examine two such systems and explain why they don't deliver as promised, though there are important nuances. At first glance, the result is striking. A disc spins seemingly on its own, powered only by springs, with no visible motor or external energy source. However, closer inspection reveals that the movements don't follow a natural pattern. If you look carefully, there's a subtle reversal in the dynamics. The vibrations and ambient sound suggest the video has been played backward. When played at normal speed, the sound is reversed. But when the video is flipped, the sound is correct, and the machine is simply slowing down. From a physics perspective, the energy a spring can store is limited, as described by the formula E equals 1/2 k times x squared, where k is the spring constant and x is its deformation. Without an additional energy source, the system cannot sustain continuous motion due to losses from friction, sound, and heat. In this case, the creator tries to replicate the previous principle with a different structure. 4 springs arranged in an inverted V-shape. The result is that the wheel fails to rotate, and this has a technical explanation. The forces generated by the springs break down into horizontal and vertical components. The horizontal components cancel each other out, and the vertical components add up toward the system's center, but don't contribute to rotation. As a result, the axle is compressed without producing effective torque. According to Newton's second law for rotational systems, this is the formula, where tau is the torque, I is the moment of inertia, and alpha is the angular acceleration. The torque is practically zero. There is not enough leverage to induce rotational motion. Every system that aims to sustain motion must harness forces to perform effective work, and the geometry of the setup prevents the forces from performing effective work. To test whether the initial system could work, we modified our own generator, arranging the springs in a V-shape similar to the original video. We will place these additional plates to connect the springs in the same arrangement as the video's author. It's ready. So now let's test it by giving it a push to see if this configuration is feasible for the inertia wheel to gain acceleration. With this spring arrangement, we lack a vertical spring to balance the tension of the angled springs, causing the generated energy to be lost, preventing the wheel from gaining kinetic energy. The first attempt failed. Let's try again. Nothing. The system doesn't work like this. This system cannot function because it only has 2 support points. It would need a third support point with a spring to provide additional force to balance the system. These springs and connecting rods should be offset at 120 degrees relative to each other to to achieve perfect system balance. But does this mean it's impossible for a system based on an inertia wheel to work? Let's find out. From these errors, we formulated a hypothesis. Perhaps the theory wasn't incorrect, but its application required greater precision. We designed our own version of the system, and the results were astonishing. As we explained in a previous video, when an initial push is given to the flywheel, it transfers its energy to the crankshaft, which induces an alternating linear oscillation in the springs. This oscillation triggers successive cycles of elastic loading and unloading in each spring, generating a forced harmonic oscillation synchronized with the axle's rotation. Some have criticized in the comments that our machine moves because the dynamo is actually the motor driving it. That's why we're going to dismantle the dynamo to conduct all our tests without anything that could artificially propel it. During this process, the potential energy stored in the springs during the compression phase is partially reintegrated into the system as rotational kinetic energy. This is possible thanks to a phenomenon of induced resonance that occurs when the system's oscillation frequency approaches the natural frequency of the springs. We call this phenomenon kinematic resonant coupling, and it can be approximately modeled with an expression inspired by damped spring mass systems coupled to a rotational mass. Here, omega is the system's effective resonant angular frequency, K is the equivalent elastic constant of the combined springs, J is the flywheel's moment of inertia, and B is the system's dynamic damping coefficient. In ideal conditions, when damping is low and the system is tuned to its natural frequency, this coupling enables extremely efficient energy transfer. The result is sustained rotation with minimal apparent mechanical losses. When we give the wheel an initial motion, one of the springs, the one most compressed, in this case, this one, begins to release its elastic energy while the opposite spring is storing elastic energy. As it rotates, once the spring has stored that energy, it releases it by contracting, continuing the motion. Thanks to the 90-degree offset between each crankshaft component, this motion remains continuous, driven by 4 parallel springs paired against another 4 that continuously store and release energy, sustaining the crankshaft's rotation. Some have tried other configurations, like connecting all the springs to a single axle. But this doesn't work because there's only force accumulated in one direction. A balancing force is needed to counter the stored elastic energy. In this setup, without opposing springs, the wheel fails to accumulate kinetic energy and the system stops. This configuration would never work. We're going to install a tachometer to measure revolutions per minute. This small adhesive strip is used to measure the revolutions per minute of the inertia disc, and we'll give it the initial push. The system accelerates until it reaches a constant maximum speed of nearly 700 RPM. All this is thanks to the formulas we mentioned earlier and the refined design. The system remains in continuous operation. With this, we've demonstrated why our system works and why others are fake or failed to meet the necessary physical principles to function. If you'd like us to analyze similar videos, let us know in the comments. Write down the videos you'd like us to review. And remember to give a like and subscribe if you enjoyed the video. Also, become a member if you'd like to support our videos. Thanks for watching.